Welcome students. Today I am going to discussing about an basic part of an electric circuit. At first I explain EMF, which is named as electromotive force, terminal potential difference and internal resistance in a cell. And later on I will explain the relation, an important relation among EMF, terminal potential difference and internal resistance. So once again welcome to your favorite channel TKG physics classes, and now let's begin the class. So at first you have to know what is cell. Cell is a device which maintain the potential difference between two electrodes. Suppose you just see this figure. A cell is mainly consist of two plates. This is one plate and this is another plate. And in this plate, in between this plate, these plates are immersed with an electrolyte solution, with some electrolyte solution. Suppose I am considering the electrolyte solution here, copper sulfate. Now due to some chemical process, there happens some chemical process, and due to some chemical process inside these two plates, they developed a non-electric force. Mind it, non-electric force. This is not electric force. Now this non-electric force accumulate the positive charge at this plate, which is named as anode, and accumulate the negative charge, accumulate the positive charge this side and accumulate the negative charge with another plate which is named as cathode. So obviously this positive plate has higher potential and this negative plate has lower potential. So there is always a potential difference between two plates, between two electrodes. This potential difference, cell is a device which maintain this potential difference. Okay. Now this is the definition. Now you have to know what is electromotive force, what is EMF. You just see the definition. It is the maximum potential difference between two electrodes. This one, the potential difference between two electrodes when condition applied, when no current is drawn from the cell. When this cell is not connected with an external circuit, not connected with an external resistance, the potential difference between two loads, the potential difference between two electrodes is named as EMF, that is electromotive force. Generally it is represented by symbol E, or sometimes you can say this one, E. Okay. So what is electromotive force? Electromotive force is the maximum potential difference between two electrodes when the cell is not connected with an external circuit. That means in case of open circuit, there is no flow of current in a circuit, the potential difference, the maximum potential difference between two electrodes is named as electromotive force. Now suppose I am connecting this cell with an external circuit, connect it. Suppose this anode is connected and this cathode is connected with an external resistance capital R. Now what happened? When these two plates are connected with an external resistance capital R, current flowing, the circuit is closed circuit, not open circuit. When the circuit is closed, current flowing from positive plate to negative plate. Suppose the current I flowing from positive plate to negative plate. Now what happened? Here in between two plates, is there any electrons or any ions? Answer is ions. There is Cu++, Cu2++ and SO4 minus. There are some positive ions and there are some negative ions. Now in between electrodes there are some positive ions and there are some negative ions. So obviously there is a chance of collision between two ions, and due to this collision the current flowing inside this liquid gets an obstruction. This obstruction is named as internal resistance. So what is internal resistance? This is our definition. The resistance offered by an electrolyte, the resistance offered by an electrolyte of a cell to the flow of current between its electrode is called an internal resistance. Internal resistance, that means the resistance which occurs between two electrodes due to the collision of positive ions and negative ions. So you just consider in between them there is some internal resistance which is denoted by symbol small r. External resistance is denoted by symbol capital R. Now what happened? Obviously this internal resistance is controlled by this internal resistance is controlled by some various factors. I will explain later. Okay, but obviously there are some internal resistance between two electrodes, and this internal resistance exists when there is a current flow in the circuit. When there is no flow of current, there is no significance of this internal resistance. This internal resistance exists only when there is a flow of current in this circuit. Okay. Now this is our electromotive force. An electromotive force, that means the circuit is open. Now obviously this electromotive force is divided in two parts. Some potential across capital R, that is named as external resistance, and some potential across this internal resistance between two electrodes. So E divided in two parts, some parts across capital R and some parts across small r. Now in general, small r, that is the internal resistance in a cell in a circuit is less than with respect to external resistance capital R. So obviously the potential across R is much greater than the potential across small r, but there is a small potential, drop across small r. So E is divided in two parts. Suppose I am writing, that is capital V and small v. What is capital V? Capital V is the potential across capital R and small v is the potential drop across small r. So in an electric circuit, this is our general expression when current flowing through this circuit, that is EMF is equal to sum of potential difference and plus voltage drop. This is named as terminal potential difference, and this is voltage drop, that is sum equal to EMF, that is electromotive force. So what is terminal potential difference, students? This is our definition. Terminal potential difference, it is the potential difference between two electrodes of a cell in a closed circuit. That means when current is drawn from it. The potential difference between this point, the potential difference between this point when current flowing through this circuit is named as the terminal potential difference. That means the potential across capital R, and the voltage drop across this small r between two electrodes is named as internal resistance, and this potential difference is named as voltage drop. This is named as voltage drop. Okay. So this is our basic part, and you see the definition of EMF, terminal potential difference, internal resistance and cell. Okay. Now the value of internal resistance depends some factors. Point 1, internal resistance depends directly proportional to concentration of these electrodes. Different electrodes have different concentration. More concentration, that means the internal resistance becomes more. And second one, internal resistance is inversely proportional to the area of plate. When the area of plate becomes more, the internal resistance becomes less, and vice versa. Third one, internal resistance is directly proportional to the separation between two plates. This is the separation, is represented by symbol D. So when there is a large separation between two plates, that means the internal resistance becomes more. When there is a small separation between two plates, the internal resistance becomes less. And Then there another part, that is internal resistance, is directly proportional to the temperature. When the temperature increases, the collision, the probability of collision between positive ions and negative ions becomes more. When collision becomes more, the internal resistance, due to this collision, the internal resistance arrives. So when collision becomes more, obviously the internal resistance becomes more. So on depending these 4 factors, internal resistance can vary, internal resistance can changes. But in general, with the respect to external resistance, internal resistance in a circuit is very small, but obviously there is some internal resistance, and this internal resistance is exist when there is a flow of current through this circuit. When there is no flow of current, there is no existence of internal resistance, and when there is no flow of current, the potential difference across 2 electrodes is known as EMF, and when there is flow of current, the potential difference across this electrode is known as the terminal potential difference. Okay. Now we will derive a relation among EMF, terminal potential difference and internal resistance. Very important relation for your numerical purpose and for your basic concept. So establish it, relation among EMF, V and internal resistance R. You know the formula of current. Current I, that is equal to EMF divided by total resistance, EMF divided by total resistance in a circuit. Here external resistance capital R and internal resistance small r. So the total resistance is represented as R plus R. So from this equation you can say E is equal to I into small r plus of capital R. So E is equal to I capital R plus of I into small r. Now E is equal to this I into capital R, current into external resistance, is named as the terminal potential difference, which is denoted by capital V, plus of this value I, current flowing through this electrolyte solution. You know, in case of liquid, the current flows the charge carrier, that is ions, positive and negative ions, and due to this positive and negative ions, they introduce a terms which is named as internal resistance. So current with the product of internal resistance is named as voltage drop, which is denoted by symbol suppose small v. So this is our relation, is important relation. Now you see some special condition here. You see from this equation you can say this is our v. So v equal to E minus of I into R. This v, this is small v. So v equal to E minus of I into R. This is equation 1. Suppose we consider in an electric circuit I is equal to 0. I is equal to 0, that means the circuit is open circuit. And you know, in case of open circuit, the potential difference between 2 plates, between 2 electrodes is named as EMF. Now you just check. When I is equal to 0, from equation 1 you can say, V is equal to E minus I into 0 into R, that is 0. So V is equal to E. So EMF is equal to the terminal potential difference. But when there is no current drawn from the circuit, when there is no current in an electric circuit, the EMF, electromotive force, must be equal to the terminal potential difference. Okay. Now you consider another case. Suppose there is no internal resistance. There is no internal resistance, R is equal to 0. So when there is no internal resistance, in that condition you also say V is equal to E, because R 0. But always in an electric circuit there are some internal resistance, always very small value, but there is some internal resistance. Now question is, when V must be greater with respect to E. There is another condition for that. Obviously, there is another condition. When this cell is charging, suppose like this way, there is a charger, and this charger charging this cell. There is a positive plate, there is a negative plate, this charger is charging this cell. So in that condition, this condition is when discharging condition. This is happens when discharging condition. But when the cell is charging, that means the flow of current reverses. The charger gives current, so the flow of current will be in this way. Current will be flow in this way. No current drawn from the cell, because cell is charging by some charger. So in that case, we can say I is equal to minus of I, because current reverses. So when I equal to minus I, you just see from equation 1, we can write from equation 1, we can write V is equal to E minus, in the place of I you write minus I into R. So this value gives V is equal to E minus minus plus into IR. So this is our equation, and this is equation 2, and this is happens when the cell is charging condition. Sometimes in your exam there is a question asked, that is, under what condition this terminal potential difference becomes more than the electromotive force? Answer is yes, this is happened, but this is happened when the cell is charging condition. But in general, when the cell is discharging condition, that means this is our general formula, V is equal to E minus IR. So in general, in discharging condition, we can say always V less than E, or you can say V is equal to E. When less than E? When there is a discharging condition, you can see this, you see just this formula, V is equal to E minus of something, so V obviously less than E. And when there is no current drawn from the cell, I is equal to 0, so in that condition you see V is equal to E, because I 0. So the relation V less than or is equal to E, this is our exact relation, but there is a one relation, that is V greater than E, and this relation happens when there is a charging condition. So this is our basic part, student, and this part is very important, is very logical for your future studies, for your solving some basic numericals. Okay. So with the help of this concept, with the help of this equation, in next lecture we will explain the series and parallel combination of cells. We will explain the equivalent EMF, what will be the equivalent EMF in case of cells in series and as well as parallel, and we solve some basic numericals, some basic and important numericals related to this formula. So students, I think this part is clear to all of you. If there is any problem, let me know through this comment section. So today I am ending here. In next class we will explain the series and parallel combination of cells. Till then, bye bye. Stay happy and continue your study.